Hi everyone. In this video, I'm going to reconstruct my recent FMC world records, the 16 moves single and the 22 moves mean. So this is the first scramble, the inverse scramble actually. And the first thing I did for this scramble was checking a few edge orientations on the normal scramble, as I usually do. They all were quite decent, and they seemed to give nice domino reductions. So the first thing I did was, the second thing I did was switch into inverse and trying edge orientation on inverse to see if there was some even better domino reduction. And this is what I found. So it's a 4 moves edge orientation on RL. It's U, D prime, F, R. And this leaves on using F and B as what you call top during the top and bottom during domino. This is a 1 wrong edge and 4 corners. So you can set it up to some case that can be solved with R, U2, R prime or something similar. And the way to set it up was L2, F prime, B2. This is one of those cases. You see, when I do, what is it? U prime, U prime, U prime, B2. Oh yeah, so U prime, B2, U. U prime actually, but it doesn't matter. This gives a DR. And the first thing that I look for when I solve when I complete the domino reduction is if I can solve corners easily. And this is the case because with R2, well, technically B2, R2 again, I solve all corners. But instead of doing, so what was it, R2, if I do BF and then D2, I only leave 5 edges, and this is a 5 cycle of edges in 14 moves. This is very nice. So I want to solve them with insertions. And how do you solve edges? I mean, if you have 5 corners, there's basically only one way you can solve it with 2 insertions. You insert a 3 cycle that solves cycles 3 pieces and solves 2 of them. So you're left with another 3 cycles of corners, and then you insert another 3 cycle and you solve them. With edges, you can do many more things, because not only 3 cycles are quite good with edges, but also double swaps of edges. So for example, R2, U2, R2, U2, R2, U2. This is a double swap, and this is just 6 moves, so it's very convenient. Or M2, U2, M2, U2. This is another very good case, and you can also use variations on these cases, like U2, L2, D2, R2, then how do I do it? D2, L2, which should be also 6 moves, and it's another way to solve this case. So there are many cases, and this is especially useful in domino reduction solves, because they tend to cancel a lot with, as you see, I use only domino moves. So yeah, as I said, I don't look just for inserting 3 cycles, but also with double swaps of edges. And there's also another way we can solve a double swap of edges, and you'll see it later. But first thing, let's go back to the place where I inserted the first commutator. Where was it? D2, F prime, B prime, R2. So here, what do I insert? I insert a simple 6 move 3 cycle. It's a D prime, U, F2, DU, R2. So it was like E, R2, E prime, R2 or something. And yeah, this is a standard 3 cycle, but it doesn't solve 2 edges, it solves only 1. And so I'm left with 4 edges to solve, as you see now. How do I go? And it cancels 4 moves, by the way. So now I'm at 16 moves with a double swap of edges left. And how do I solve them? Well, I could look for places into my skeleton that leave one of the cases that I showed you before. But what I did was actually this, 2 moves from the end. What was this? So D2, F prime. I can do E2, so it's a slice move, and then F D2, and you see that I solve all edges, because what does E2 do? So let's try on a solve cube. E2 swaps 4 centers, but let's ignore them for now. And then it swaps this edge with this edge here, and this edge here with this edge here. So it's a double swap of edges. And it's just 2 moves at the price of not actually solving the edges, but messing up with centers. But that's fine. I can insert centers, and I I only used 2 more moves, so I'm at 18 moves, I think. And at some point I can insert, so I have to go back now, d2, f prime, now e2, b prime, and I think here I can insert, yeah, because if that's after the first insertion, I can insert centers with e, m2, e prime, m2. Now I messed up centers, but no edges, see? If I do it on solve cube, it's e, no, what is it? E, m2, e prime, m2. This is an 8 move args, but it happened to cancel 6, and that's quite good, but not so uncommon for this kind of solves. And now where am I? B, E2, F, D2. And this is a 20 move solutions, and it's actually the first solution that I found. And it's obviously very good. Yeah, so one thing that I do when I have a good solution, quite some time left and little chance to improve it by trying other things, other starts, different skeletons and stuff like that, is to look for pieces in my solve that don't look optimal. And for example, here we have this sequence of moves here, and if you ask me how I picked a specific sequence and try to improve that, it's hard to say. It just doesn't look like it's optimal. It looks like it can be improved. And in fact, if you do u prime d, b2 d, b2 u, and then you see this can solve quite easily just with 4 moves. And I use 6, so it's like d prime r2, d prime r2. So this solution can be replaced with the inverse of what I used to solve it, so r2d, r2d, and it happens to cancel. So I removed 6 moves and inserted 4 to get the same result. So I saved 2 moves, but actually I happen to cancel 2 with this r2. And this seems like incredibly lucky, but actually if I were a little bit smarter, and if I didn't pick this sequence of moves to replace, but a longer sequence started from this r2, you see r2, u prime d, b2, d, b2, u, and then this is obviously a 3 moves case. So I ended up replacing this 6 moves with my 4 moves and cancelling 2 for a 16 move solve. Okay, so second and third solve are much simpler to explain. And this is the second scramble. It's actually the inverse again. And I started with the easy 3 moves edge orientation, R prime, L, F. And then I also have 2 pairs. And if I do R, F2, I get, well, another pair and I build a square. And this is a pseudo square. So I knew with U2 and normal, I would get 2 squares. So I immediately switch to normal. And I can do U2 for the easy square, and I have 2 squares now. And then I can build 2 by 2 by 3 pretty easily with R prime, L prime. I could have done L2, but R prime, L prime just works better here. U, R2, L2, and I have a 2 by 2 by 3. Say it's on the wrong axis, but still it's pretty good. And then what do? Oh, I can build easily a pseudo F2L minus 1 by inserting this pair with R, U2, R prime. I think I also cancel 1, yeah. And I also build this pair, and there are actually other ways to do a pseudo F2L minus 1, like L prime, D prime, L, and then I still leave this pair. I can do something like this. I mean, I tried many different things, but in the end, this is what worked out better. So I said R, D2, R prime, and then I just insert the other pair, and I get 3 corners in 19. I was a bit unlucky with insertions because the optimal only cancelled 1, but not a big deal, since in the last solve I actually got 19 to 3 corners as well, but I cancelled 3, so that kind of evens out. So yeah, this is basically the second solve plus an easy 3-corner insertion. Okay, so last scramble, again it's the inverse, and this time I opted for quite a long edge orientation, but it left a good continuation, so I went for it. What did I do? That's like, yeah, it's an FB, so I have 4 bad edges. It's like L prime, R prime, U, R prime, B. B, yeah. But it leaves, you see, 3 pairs. So this is decent. Then again with LB2, I build a square, but actually I also have a pseudo square here. So I know with F2 and normal, I will get 2 squares. So I switched to normal, I found the pre-move, but when I switched back to inverse immediately. And this is the inverse scramble with pre-move, so I can repeat the edge orientation. What's it, B or B? LB2, and then I have 2 squares, right. So now there's an easy 2 by 2 by 2 block here, that also happens to be 1 more pair. And here I played around with this part quite a lot because I have 1 more square here, and I can do all sorts of stuff. And in the end, I found this 19 to 3 corners pretty quickly, and I couldn't improve on it, but that's fine. So what do I do now? Okay, so immediately L to build this other square, and then F2 to save the pair, and then L prime, that was it, L prime F2 to build this. I actually destroy this, focus. I actually destroy the square in the process, but then I have an easy F2 L minus 1. And then I think I just insert in this pair, just 3 corners, yep. And the insertion cancels 3, so I get a 24. This was 19 to 3 corners. So this was it, so as simple as that. Yeah, so this was the last solve. And so 16, 26, 24 makes a 22 mean. This is just crazy. I don't know, the 16 was just so unexpected. I don't know what to say. Yeah, so hope you enjoyed the video. Like, subscribe, whatever, or don't. I don't care actually. And drink responsibly.